Hello and welcome to CSA's webinar series, CSA Cloud Guide. Today's webinar is entitled Preventing AWS Misconfiguration and the Risk of Data Breaches. A few housekeeping items before we get started. During this live presentation, you have the opportunity to submit questions at any time. Just use the Ask a Question tab at the bottom of your screen. Time will be reserved towards the end of this webcast to address these questions. The slides from this webinar will not be provided. However, you can access the recording anytime. Just use the same link to view the webinar again. Today, we are excited to have presenting with us Josh Stella. He is the co-founder and CTO of Fugue, the cloud infrastructure automation and security company. Previously, Josh was a principal solutions architect at AWS, where he supported customers in the area of national security. He has served as CTO for a technology startup and in numerous other IT leadership and technical roles over the past 25 years. So we're really excited to have Josh presenting with us. Thank you everyone for joining us, and I'm going to turn things over to Josh.
Thanks much, and it's great to be here, and thanks for everyone who's joining us for the webinar today. I'm Josh Stella. I'm a co-founder and the CTO of Fugue, and I also have with me Drew Wright, a co-founder of Fugue, and he's going to help us a little later in the question and answer period. So we're going to be talking today about preventing AWS misconfiguration and the risk of data breaches. And there are going to be a few aspects to this as we get into it. I'm going to be showing a lot of data from a survey that we conducted of over 300 advanced cloud users who are operating at scale around these problems. We're going to frame the problem, and then I'm going to describe what we think is the best solution to it. It's not going to be a product pitch. It's really about how self-healing can help with this as an approach to solving for misconfiguration. So I'm going to go ahead and dive in. So Neil McDonald from Gartner, I won't, well actually I will read this one. Through 2020, 80% of cloud breaches will be due to customer misconfiguration. Mismanaged credentials or insider theft, not cloud provider vulnerabilities. We're going to drill into this more, but I saw this a lot when I was at AWS and now at Fugue, we see it as well. It's very common for us to go into a customer and identify a security misconfiguration in an hour or so. It's a common problem. And we're going to drill in a little as to why that is and what the risks are and what can be done about it. So cloud misconfiguration is a big security risk. You just saw the 80% number. When we did our survey, which is where this 93% of folks concerned for major security breach due to misconfiguration, that number comes from our survey. We published that survey, and David Linthicum of InfoWorld gave us this quote, you know, the complexities of cloud computing and the chance of human error will bite you in the butt. And that's true. It's true for all of us. You see it in the news that these risks are very real. These are all data breaches, not due to attackers being clever, but due to users of the cloud getting their configuration wrong. And I think that it's too easy to point the finger at the human beings who are doing the cloud implementation. And it's also too easy to point it at the cloud service providers. And what I mean by that is human beings are really bad at keeping track of large numbers of details. And when you think about a large-scale deployment on cloud, every single service has an API where everything has to be configured correctly for it to be secure, compliant, and functional. And that's just too many things for humans to keep track of. Well, I've also heard people say, well, the cloud service providers make it too easy to get things wrong. And I disagree with that as well. Those are features, right? In these cases, those features were not set the right way for the use case. But in other use cases, you want that information to be publicly exposed. So I'm saying it's kind of no one's fault given the tooling that's been out there, but now there are approaches that work to solve for this. So the cloud does create new security challenges. Very often, traditionally in security, we've thought about perimeter defenses on networks, we've thought about endpoint protection, we've thought about attack detection. But in the cloud, as we saw, according to Gartner, a lot of the risk surface, the quote-unquote attack surface, is the configuration of the cloud services. And that's because it's API-driven infrastructure. API-driven infrastructure is awesome. You can go really fast. You can have very low cost. You can experiment. Your developers, therefore, are making infrastructure decisions, and they're doing it quickly. So this API-driven infrastructure and speed you can get from it is a huge benefit, but it also creates challenges at scale. And those are exacerbated by a constant flow of new services and operational patterns. So if you're familiar with the evolution of cloud, you can think about in early days it was kind of like a remote data center. There would be virtual machines and software-defined networks, and all that stuff is still there. But now security has to be concerned with things like access, identity and access management of things like serverless functions and NoSQL databases. There's no longer the network perimeter and the machine image. These are kind of higher order services, and that presents a challenge to security. It presents a challenge to everyone, but also to security. So these combine to create these challenges at scale. What's running where? Is it in compliance? Well, was it in compliance when it was deployed, and is it still in compliance with policy? And are we adequately addressing risks in a timely manner? And you'll see later, we'll argue timeliness changed with cloud. You have to go faster than in the data center. So a little bit on the shared responsibility model of the cloud. I think most people have probably heard about this. But when I talk to a lot of CISOs, they're not fully aware of how much is on their plate. So I'm going to go kind of from the bottom up. The cloud service provider is responsible for the physical plant, for the network cables, for who can go onto the data floor, the physical boxes, the hypervisors. And then from north of there, it's really up to you. So you are responsible for security on the cloud. And I think a lot of folks have been thinking about this in terms of moving their data center style security into the cloud, putting agents on boxes and, running intrusion detection and things like this. But the elephant in the room is the configuration of the cloud services, right? So that's really what we're going to be talking about today. So this is data from that survey I mentioned earlier. Over 300 organizations, all running at scale on cloud, responded to this. And we asked a bunch of things, but one was, what is causing cloud misconfiguration? The first and largest category here is human error, but the other two are forms of human error. So there's a theme. Humans aren't getting this right. So 64% said that, 54%, and obviously these are not exclusive of each other. It's well over 100%, but 54% also said lack of team awareness of security and policies. And this gets to another theme I'm going to be hitting on, which is getting security and compliance on the same page with the development teams and doing it in a way that's friendly to modern practices on cloud for everyone. And then 49% lack of adequate control and oversight. Well, most control and oversight today is done manually by human beings. So we're going to be proposing, you can probably guess, automation for this. But this gives you an idea of what people told us is causing their misconfiguration. So the common types, 66%, if you're not familiar with IAM, it is identity and access management. It is the permission system and identity system in the cloud, in AWS's cloud. So this is how not just your human users access the cloud, but how components within the cloud environment, say a container or a Lambda function, access other components in the cloud. So this is a big attack surface, and it's the most common thing to get misconfigured because it's very complex. Over half said security group rules get misconfigured. Security groups are functional equivalents to firewalls, so that's not great. Over half said object storage access policy. So a lot of those data leaks we showed earlier were due to data that should be actually private or constrained to a relatively small group of users being shared publicly or having encryption turned off. And then the last one, of course, encryption in transit disabled. So if you have a large cloud footprint, you probably have some of these things wrong right now. That has been our experience, my experience at AWS, and our experience here at Fugue for a number of years. So let's talk through what our survey respondents said about the challenges of managing this cloud misconfiguration. Yet again, the first two of these are 100% forms of human error. The first is just generic human error. The second is the challenge of training team members on misconfiguration. I would argue that this is a challenge that can be massively reduced as a challenge, that training is inadequate. But almost half said, you know, it's hard to train people. Well, you have hundreds of services and millions of potential configurations. Of course it's hard. The next two are really about how people have been using kind of first generation or sort of old school scan and report tools to help them with this, where these tools tend to just watch for any change to the cloud environment and then throw events at you. And what this does is it creates a ton of false positives and alert fatigue. And the net result of that is a longer mean time to remediation. And I'm sure most of you know what I mean by that, but if you don't, the mean time to remediation is from the security event happening to it being fully resolved. Needs to be really fast. So if you're going through lots of false positives to find the things that actually matter, that is going to lengthen your MTTR, and that is going to leave you exposed longer. So what is okay on the cloud in MTTR? So what we've got here is the y-axis represents greater risk, greater exposure. And the x-axis across the bottom is talking about time. So we're saying here that the infrastructure risk for misconfiguration goes up. We've got it linearly here. May be linear, may not, but it's going up every minute. There is a greater chance every minute that misconfiguration is out there that a bad guy is going to find it and exploit it. And so the manual process of remediation, a scan tool throws a ticket into a ticketing tool, it gets triaged amongst others. So you get through the detect, then identify, you know, do we need to fix this? Is this a normal thing? Is it a bad thing? Then we need to repair it, then we need to verify it. That manual process can last hours or days, and that's just way too slow in the cloud environment. The risks are too fast-paced. So the automated form of this time to remediation is the answer, just like it is, you know, for the bad guys. And they are developers, and they are faster than you are at a keyboard because they're running algorithms. They are running programs looking for your mistakes. And the cloud service providers are really good at eliminating a lot of this. But like anything else, some get through, and we just saw that on some of those earlier slides. So the only way to fight programs is with programs, because programs are just so much faster than human beings. So what we learned in our survey is that the current state of the world is that we're really not okay with MTTR. 86% said actual MTTR is often 1 day or longer. That is an eternity on the cloud. And 58% said the ideal MTTR would be less than 1 hour. And the good news is that's absolutely achievable right now. So it's also expensive to do this manually or semi-manually. About half of our survey respondents dedicate at least one person to managing this configuration. More than half identify half of alerts as critical and in need of remediation. and almost 80% said it takes more than 5 minutes just to prioritize a single alert. So this is slowing down your MTTR, but you're also spending money on expensive people to do this. So our goal, we believe, should be resilient cloud security. It needs to cover all critical cloud resources and related security rules, and it needs to recover automatically from misconfiguration events, whether due to human error, pipeline deployments, or malicious actors. So let's talk about current remediation methods. There are really three. Manual is sort of still with us from the data center. It sorts through lists of alerts and false positives, prioritize manually, fix and report manually. The second, which is gaining in popularity, is to use automation scripts that deal with very particular misconfigurations, like is a SSH port open to the world in one of my security groups? And just look for that. And if you find it, turn off that access. And the third one is self-healing. This is what we at Fugue think is the right approach. And it's based off of known good baselines and detecting drifts from those baselines, and then the ability to revert back to the baseline. And I'm going to keep coming back to this baseline concept because that actually is the contract between security, compliance, and development. And that'll make more sense as we drill into it. So of these methods, manual is just too slow, it's too error-prone, and it doesn't scale. We feel comfortable just stating that outright. It's not the right approach for cloud. So that leaves us a couple of other options in automation scripts and in self-healing. So remediation itself really does need to be automated. 80% of our respondents believe that it will help keep data safe. Almost 80% believe that it will help ensure compliance, and 75% believe it will help improve efficiency. We know these folks are right on experience. So let's talk a little bit about remediation with scripts. And you might hear these called bots. Some folks refer to them as remediation lambdas, referring to AWS's Lambda serverless compute functionality. But it's all kind of the same, which is you develop and deploy some automation. Now you're going to have to develop scripts or borrow them or get them from a vendor for every possible misconfiguration. And if you think about that for a minute, that is not something you're ever going to make complete, right? You're going to have some limited number of things you're looking for based on the number of scripts you have, and the logic of what you're looking for and what should be done is all in source code. So by doing this, you're taking on creating and maintaining a body of source code over time. So first you have to develop and deploy that stuff. And there are a number of tools out there that will help you with that. So step two is that misconfiguration is identified, right? One of the things that you wrote a script for is seen as, well, that happened, port 22 is open. And then that triggers an action in the tool. In this case, there is some kind of playbook in the script for taking a quote-unquote corrective action. It may be corrective, it may not. And just one example of that, I was talking to a friend of mine just the other day at a large Fortune 100 company, and they had deployed remediation scripts, and one of those remediation scripts misidentified some critical infrastructure as non-critical and deleted it. That's a risk in this approach. So those challenges, again, the scan and report tools generate alerts after the fact. The blacklist approaches, here's the list of things that you cannot do, will never be comprehensive and must be continuously maintained. And the remediation typically only covers a small subset of infrastructure. Maybe it's just security group rules or security group rules and some virtual private cloud network stuff. These are challenges. They can be overcome at lower scales, but as you start to really build out that library of scripts, you're now owning that over time, and you're going to probably be constantly adding to it as new services appear, et cetera. So you end up with some false positives, some maintainability that I was talking through, as well as scalability issues, adapting to new and dynamic environments. Every time a new service comes out, there's going to be a need to potentially add to that collection of scripts. Oh, there we go. So now I'm going to talk about, and I'm biased. I think this is a better approach. I have seen people be successful with the scripts approach, so I'm not totally writing that off, but the challenges are substantial. So with self-healing, we take just a very different approach to this problem. And step one, and the big important step, is establishing a baseline. And it says here, take a snapshot of running infrastructure to establish a baseline. There's much more to it than that. This becomes where the security team, the compliance team, and the development and ops teams, or DevOps team, or however you're structured, can all agree, can all have a contract with each other. So for example, if one of the policies is, thou shalt not open port 22 to the world, if that collection of infrastructure has that port open, up front in the development process, security and compliance can give feedback through tooling to development that, hey, you're breaking a rule there. That's not going to go live. We're not going to allow that. And they can have a dialogue until they all agree as to what a correct baseline really is. So this actually shifts left a lot of security and compliance process and practice instead of being a gatekeeper at the end. So the baseline is a huge part of this approach. So once you have that baseline, any change is drift, right? If you want to change the baseline, you make changes, you establish a new baseline. But while that baseline is in place, we can now eliminate the false positives. Only things that drift from the baseline matter because we know the baseline was good. And so it eliminates a lot of the false positives, and it respects the contract. Then in a self-healing system, rather than having to write a bunch of source code, you can have a codeless form of automated remediation. A properly done self-healing system knows how to revert any change to the correct baseline. So the configuration is restored to the established known good baseline. So going back to my example of a moment ago where security started running bots and accidentally deleted something important, that would never happen with self-healing because those important assets would be part of the baseline, and security would know about them and have signed off on them early in the process, and therefore won't misidentify them as a problem. So I talked a fair amount about this, but we'll go through it in a little more detail. So we've got here DevSecOps on the left, but whether or not you're really doing DevSecOps or you have DevOps and security is separate and compliance is separate, really doesn't matter. The point is the combination of those functions, development, operations, security, and I would add compliance, need to agree. And with the baselining approach, they get to agree up front and all say, yes, sign off on it. So a lot of times, well, not a lot of times, this kind of requires security and compliance to be tool vendors, not auditors. You might still audit, you probably will. But the cool thing about this approach is by implementing policy as code, you can provide developers and operations folks a tool to know in advance before going into production whether or not that infrastructure is compliant. And if that tool's good, those developers are going to be able to see as they write code that affects the environment whether or not that is in policy, and if it isn't, why not, which policy, and what needs to be changed. This allows integration of policy checks into CI/CD toolchains and provisioning tools. So instead of it being a pick up the phone or send out a ticket to look at an environment by security, security has vended out the policy as code. When the CI/CD pipeline or provisioning tool builds that, an API call can be made to compare that development environment to the policy as code and give immediate feedback in the developers and operations folks' native tool chain as to whether or not they're in policy, and if not, why not. So that's the pre-deployment side of establishing a known good baseline. But then once you're in deployment, just enforce that. Enforce the known good baseline. That means identifying any drift for any reason and being able to revert any drift back to the known good baseline without a big library of scripts looking for very narrow misconfiguration scenarios. So we propose that this should be built in across the entire software development lifecycle. Here we're showing Jenkins being considering using the tool for policy validation as part of the build process, where if you're familiar with CI/CD tool chains, what will happen is you've got a bunch of source code and you've got infrastructure as code, and something like Jenkins picks that up, does all the builds, and then goes through a series of tests to decide whether or not it's acceptable, whether it has succeeded or failed. And so in a self-healing cloud world, what you would get then, if it's a policy were to fail, port 22 open, you would get a build fail. And developers are used to that. They get a lot of them. And that's speaking in their language. So this approach allows security and compliance to actually be tool vendors to dev and ops instead of gatekeepers. You become highway builders instead of toll booth operators. And I've been kind of hitting on this theme a lot, but we think it's extremely important on cloud, that bridging the divide between these groups. So using this approach, the compliance teams can automate policy checks earlier in the process, so again, shifting left, and gain better visibility into the pipeline. So it gives compliance teams more information sooner, as well as the other teams. Security teams can then assert what policies they need for those environments, which will done properly, where you're doing this process in an automated way all the way through the software development lifecycle, beginning in development. That means you can eliminate misconfiguration prior to provisioning and production. And of course, dev and infrastructure teams can move faster by identifying and fixing security problems earlier in the SDLC. So I spent some time prior to being at Amazon Web Services working in very large organizations with very complex certification and accreditation processes, where CNA might take certification and accreditation, might take weeks to get through. Well, if you think about a modern agile cloud model, you might be doing a release every 2 weeks. So shifting that stuff left and giving those developers feedback as they're developing actually empowers them to get it right? The DevOps teams don't want to break policy, but they also probably don't want to read the 3-inch thick 3-ring binder of what the policy is. So they're well-intended, but they have other things on their plate. And this approach works natively using their tools so that they can do the right thing and without a lot of effort. So let's talk a little bit about where to start. So the first thing we think you should do is apply a policy to an existing cloud environment. In almost every scenario where we're working with new folks, they'll say, we think we're pretty good, and we'll take a look at whatever policies they have implemented, and we'll look through the environment, and usually inside of about 20 minutes, a bunch of things have been identified that they were just unaware of. And again, going back to this isn't that they're bad at doing cloud, it's that cloud's really hard to do well at scale because it's so feature-rich. So identify the violations, work with developers to fix the issues, use CIS Benchmark. CIS Benchmark is a great starting place. If you're not familiar with it, it's a collection of best practices. We've implemented it as policy as code. Others have too, so that you can just quickly check and see, are you doing cloud the way that AWS or Microsoft recommend to do cloud? There are benchmarks for Azure as well. You might also be concerned with other compliance regimes like GDPR or PCI or NIST 800-53. We have encoded all this as policy as code. The point I'm trying to make is these things can all be brought into an automated environment as policy as code, and you can go see what you have out there and how it compares to what you think you should have. So that's a good step one. It can be done quite quickly. Just to give you an idea of where you stand. The next step is to learn what your app developers are doing. How are they using CI/CD tools? Where can security and compliance fit into the existing process and live alongside it? What are they using for infrastructure as code, if they're using that at all? Do they have policy checks in place? Do they know the security best practices? Are those shared in a useful and efficient way? So step one, learn about the environment. Step two, learn about your other teams, looking for those integration points where security and compliance can get involved and shift left in the process through the baselining. And then the third step is identify critical cloud resources and establish baselines. So where you really need this most are on those services and environments that carry a lot of risk. So you definitely want to baseline and do drift detection and probably autonomous remediation on things like firewall rules, security groups, on things like network configurations, on things like object storage buckets that can be accidentally unencrypted. You may step into it a service at a time or a couple services at a time. That's okay. We often see in mature environments using automation, only the most critical things have the full self-healing pointed at them or automated remediation scripts, but on other things you're monitoring, right? And that's fine. So monitor for drift. Monitoring generically without a baseline, you need a baseline to detect drift. You need to know what's good to detect drift. So we think it's much better to monitor for drift than just monitor for anything that looks suspicious because of the false positives in the latter approach. So this is how we recommend you measure and test your cloud security resiliency. And I want to take just a moment to talk about what we mean by resiliency. So Netflix made chaos engineering famous, right? Chaos engineering in the Netflix model is they have a tool called Chaos Monkey, and Chaos Monkey goes out and breaks stuff, kind of randomly breaks stuff. The same can be done for security, and it's important to do it because if you're not testing in unexpected ways, you really don't know if you're resilient. So I'm going to come back around to that, but resiliency in our mind is the ability for the system to survive unexpected misconfigurations and unexpected problems. So the first thing to do is to measure, determine your MTTR, decide what's an acceptable MTTR for critical cloud resource misconfiguration. Develop those targets and a plan for achieving them. Don't take on a world at once. figure out what are the most critical things, what needs to go fast. We often see folks will do things like on the really high security potential, attack surface kind of configuration items I talked about earlier, security groups, IAM roles. They might be examining them every 5 minutes in an automated way with enforcement turned on, with remediation turned on, because they need that very fast MTTR for those outward-facing high-risk components. But for other things, they might only be checking, every hour or twice a day. But it's important to measure it, and it's important to have specific goals and targets for it. And then test the resiliency. Again, going back to using chaos to improve resiliency. Attack the infrastructure security, misconfiguration. By the way, do this in dev or test, not prod. You'll see with Netflix, they do a lot of chaos engineering in production. That's because they're designing systems to be operationally resilient. Like if a server goes away, does a new one spawn? They're not doing that to open security holes, and that's what we're talking about here. So you want to do this in the dev environment and in the test environment, where you're attacking that cloud infrastructure by introducing intentional misconfiguration of many kinds, and then see how resilient your automation is. Did everything get fixed? Right? If you choose to go down the automation script path, this will start to show you where you have gaps. If you're seeing long MTTRs, right? If it takes too long to fix it, as well as the manual processes for improvement. So as you're going down this path, as with most things in tech, it's best to start in a pretty tight way and do some tests and measurements. We think these are the big ones to start with. So with that, I'm going to turn it over to my co-founder, Drew, who's going to help me with any questions folks have.
Thanks, Josh. We've got a couple here. Anybody that wants to ask a question, please enter it now, and we'll be happy to get to it. So first up is, how do you do baselining on containers and ephemeral workloads?
That's a really good question. So what you're typically going to be doing, and let me, for folks who aren't as familiar with containers and ephemeral or immutable infrastructure patterns, I believe what the questioner is asking here is, if you have things that are by their nature short-lived, how can you baseline them? You would have to baseline constantly, really in rapid fire. The short answer is the baselining approach. So if you look at these ephemeral workloads, they're usually implemented in kind of two main sets of technology. One is containers, which in the cloud run, as in most places, on clusters. And the other is so-called serverless, functions, Lambda functions, things like that. These are both approaches that are short-lived. But they live in a security context that is long-lived. They live in, when you think about the old days of like perimeter defense in the data center, there are some kind of equivalent things in cloud. So for example, I'll hit Lambdas and then I'll go to containers in a second. With Lambdas, they're communicating via access roles. Are those access roles right? So you're probably not going to baseline the actual container, elements inside the container or the source code in the Lambda, but you can get a long way by making sure the VPC that the ECS cluster, if you're running containers on AWS, is located and is configured properly with the right access rules, the right IAM roles, the right security groups, et cetera. So I wouldn't recommend baselining for systems that are designed to mutate all the time in the runtime, but the good news is there actually aren't a lot of misconfiguration attack surface inside of those things.
Great. Next one is, what is the best method for someone assessing a company's AWS configuration, get evidence to show what is configured correctly or not?
It's a great question. I don't want this to be pitchy. I've stayed away from that. We do that. We can do it in about a half an hour to an hour. with an audit that's automated and really easy to run. There are other tools out there that can do this too. What you're going to be looking for is a tool that is thorough, that has all of the compliance and policy libraries that you need for your environment. So if that's HIPAA or CIS benchmark, and then it needs to be able to thoroughly and quickly scan that environment and produce an initial report to let you know your status. And so, of course, I'm biased toward Fugue, but there are others who do that as well. But those are what you're looking for.
Okay. How can we go about measuring our MTTR today?
You're probably, if you're like most folks, you're probably going to be doing that through whatever you're using for your service tickets, your manual service tickets, ServiceNow or whatever, where, and many of those products have built-in, timekeeping on how long it takes to resolve something. So the first thing I would do is go and find that system wherever you are, if it exists, and try to extract that data in a way that is meaningful to the cloud. Like, how long does it take for a security group misconfiguration over the last year to be resolved? Because if you're running at scale, I guarantee you it's happened. I guarantee you there are tickets that tracked it. So that would be my recommendation of a starting place.
Okay. Any specific tool recommendation for DevSecOps on AWS environments?
Yeah, I mean, there's tons of great tools out there and in different categories. So, for example, for provisioning is important. Terraform's good at that. AWS has a number of tools. Obviously, we think the existing tools are inadequate, so we built tools, so we make tools. Other vendors make tools as well. I'm biased, so it's hard for me to make a credible, specific recommendation, I suppose. But I think for provisioning, I could recommend Terraform. For CI/CD, Jenkins is good. AWS's native tools are good. Circle CI has worked well for us, so I hope that helps.
And perhaps there's an opportunity there to differentiate between, app security versus infrastructure security.
Oh, that's a really good point, Drew. Thank you. I wasn't thinking about that. So when you think about like source code and application security, you're going to be thinking about tools like Sonatype and things like that that are making sure the libraries that you're shipping aren't vulnerable. What we're really talking about are the configuration of the cloud APIs, and that's a different set of tools.
Okay. What are the most common misconfigurations that you saw during your work at AWS?
All right, the number one misconfiguration that I saw when I was at AWS, and I see every day now, is too broad of permissions in IAM. So IAM is Identity and Access Management. It is an extremely powerful and capable service that has a ton of features. And as we all know, going back to the beginning of passwords in computing, if you're a developer, you might struggle for a little while with some permissions and then say, you know what, I'm just going to open the aperture, right? I'm not going to use really a least privilege model because narrowing the privileges is hard. That is the most common misconfiguration I've seen on AWS since IAM was introduced. Another is failure to use encryption. A lot of these things are kind of buried in the weeds. That's a very common one. You might think you're using encryption everywhere you can, and you'll find gaps. Another one is I cannot tell you how many times we've gone in and done an audit, and this is whether I was at AWS or at Fugue. Of course, at AWS, I was doing it manually because Fugue didn't exist. Go in and see ports open to the world that really should not be open to the world. So I'd say those are the big ones. But there's others. S3 bucket misconfiguration is very, very common, as shown by those data leaks. But I'd say those are kind of the big ones.
Okay. Next up is why aren't excuse me, why aren't CASB vendors doing configuration audits?
I don't mean to be glib here, but I think it would be better to ask them. We think it's really important. We think there's no other way to actually know your posture, but I can't speak for the CASB vendors.
Okay. How do you monitor permission configuration drift on native database stores?
So native database stores can mean a number of things. I'm going to have to kind of choose an interpretation. Let's say, for example, if by native you mean cloud native, let's think about DynamoDB. So DynamoDB, if you're not familiar, is a NoSQL database. It is very popular, again, very powerful. It scales to huge transaction volumes and huge data sets. And it gets accessed with those IAM roles I was talking about before. So as you think about permission configuration and monitoring it, the way you can do that is by asserting policy into your baseline about those roles. Right? So you're no longer needing to look for bad traffic. This isn't about the TCP/IP layer in cloud native. It's about the API layer. And a lot of that is done through identity. So I hope I answered the question regarding what a native database store was in that context.
Okay. If I'm constantly examining my environment, won't I risk AWS throttling my APIs?
The answer is yes, you will. And so you have to be selective and careful about the rate at which you're going against what services. You have to have a lot of knowledge of what the APIs are. Like tool vendors like us that came from AWS, we're really aware of this, and so we know the best practices. If folks aren't familiar with this, if you're using Amazon Web Services or Azure or GCP, they have to put some limit on the number of times you can hit the control plane APIs. An example of a control plane API call might be like create a database, or modify a network, or tell me the configuration of that resource that I created before. Well, those latter ones are typically called describe calls. They have different names. And yeah, if you're scanning the environment, you're going to be using some of your quota for those API calls. And what the cloud vendors, the reason for this is they could get DDoSed, right? They could get hammered with requests from one customer that effectively make another customer's requests not get through. So it's very reasonable for them to do this. So you do have to be careful, and this is why we recommend as you're getting into this continuous monitoring, go fast for the things that really matter from a security posture, and kind of back off on the stuff that is a little less risky, and maybe back way off on some things that you're not that worried about. Maybe every day is enough to re-audit for certain kinds of resources, like a DR site that's not online or something like this. But in your production environment, the security groups and the IAM roles and so on, you're going to want to go fast on those because you're exposed to a lot more risk. And it's always a balancing act. You can also get particular services that are highly sensitive to throttles, like elastic load balancers, for example. It's really easy to trip the throttle on elastic load balancers. So for those, you want to include them in an environment that is only getting scanned or audited, whatever you want to say, probably an hour, maybe a little faster. But it's a black art, but it can be done. Okay.
Next up, for me to create a baseline of IAM permissions, I have to profile almost every IAM role. How can I build that profile and structure them so that they have least privileges?
That's a great question. There is no silver bullet to the latter part. For those who, again, aren't familiar, IAM policies are collections of permissions that are associated with roles. So, for example, you might have a Lambda that needs to talk to a DynamoDB database. There's an IAM policy in place that says this Lambda may do read and read-write and these other 9 things on this DynamoDB. So if you've been operating on cloud for a while, you probably have a bunch of these laying around. So the first thing to do, I would argue, is find out what you've got, but immediately stop making errors, right? Immediately stop making mistakes. And tools like Fugue, and there are others, can do some introspection on those and tell you where you're not meeting some best practices. But as you're trying to get down to actual, minimum permissiveness, there's going to be some work there if you've got a pile of these out there that you need to get through. I'm sorry. I wish I had a better answer.
Okay. Is policy as code best enforced through the CI/CD tool, or is a separate tool needed?
Okay, so the way I've seen it done, the way we do it, I don't know about others. I'm not aware of a lot of actual policy as code out there. The way we've thought about this is, it's not, the answer is we do it through the entire SDLC. So the CI/CD tool isn't running policy as code. It's calling out to a tool that understands how to do policy as code, in our case, Fugue, to come back to the CI/CD tool with the result of that inline automated audit. I'm not aware of any CI/CD tools that kind of natively do policy as code. It tends to be a pretty specialized and frankly, pretty rare thing. But the CI/CD tool can call it. And then in the production environment, if you're using self-healing, the CI/CD tool is now out of the picture. It's done the deployment. Now it's up to that self-healing tool, that Fugue or equivalent, to be constantly comparing that infrastructure back again to the policy. Okay.
How do you allow for rapid change in your application when everybody has to adhere to an already established baseline?
Yeah, so a great question. You probably don't want to baseline everything if parts of the system are moving fast. And the reason I say it that way is I've had people tell me, oh, everything changes all the time. That is very rarely true. It is almost always true that some parts of the system are frequently being mutated. For example, your container cluster. You're going to be changing that all the time. Well, don't baseline and enforce on that. But try to get the longer-lived components. And for example, your software-defined network, your VPC network, your IAM roles, your security groups, these things tend to move much slower, where you can make an intentional decision to make a change and then re-baseline and get all the stakeholders in the room to say, okay, this baseline is the new contract. So put another way, if you have an environment where parts of it are experiencing frequent mutation, you're changing it a lot. Part of that contract of the baseline is we're not going to baseline and enforce this part. It's up to you guys in DevOps to not mess up too bad because you need the flexibility to go fast. And that's a totally valid choice to make. So I'm not advocating that you have 100% penetration into every aspect of the system for baseline and enforcement, but more the things that are relatively slow moving and can use the baseline approach.
Okay. How can we get buy-in from app teams when they are resisting any kind of security automation that might make a change to an environment?
Don't implement security automation that might make a change to the environment. Nobody's going to like that. The example I gave earlier, and this has to do, again, with that baseline as contract. The way, let me start over and take it from a positive perspective. If you, as security folks, can offer your developer groups tools that help them, that's much better, and that are transparent to them. So when they're in the development process, they can see as they're writing code and doing Jenkins and doing pull requests and going to dev, they get back a build report that says whether or not that thing is allowed. That's a very developer-friendly experience. So I would say come bearing gifts. Come bearing gifts of tooling instead of surprising them in production with things that could potentially break things. And that's usually where the resistance comes from, is because there's no single source of truth and trust. There's no agreed upon contract. There is a lack of trust, and that breeds resistance. So come bearing gifts, give them tools, they're going to appreciate it.
Okay, we're starting to use automation scripts and want to know if you have a rule of thumb as to when they become a maintenance concern.
Yeah, so two things. One, just keep track of the lines of code, and that's going to tell you a fair amount. So in one public repo of a number of automation scripts I've looked at, one of the automation scripts is there just to make sure flow logs are turned on VPCs. That's all it does. And it's almost 300 lines of code. So if you find yourself, if you're at a place where you're just trying to turn off bad ports on security groups and you have one script and it's 80 lines of code or 100 lines of code, you're probably okay. If you start collecting lots of code and all of the logic for remediate, right, there's no known good baseline in that model. So you don't know if the remediation that script is going to do is acceptable, right? You only know that it's what you thought was right. There's no contract, there's no baseline. The other thing to look out for is if you're starting to run into conflicts between security and ops, DevOps, you're probably hitting the wall with automation scripts efficacy.
Okay. Do you recommend allowing only secure development libraries at the first place and block vulnerable development libraries, or address them during the validation gates using policies?
So, okay, I should go back and say what I've been talking about here in terms of this webinar is really about cloud misconfiguration. We're talking about the cloud APIs. And this is a question, it's a good question, about source code libraries that you're pulling into your project. So those are kind of different domains. I would argue that in almost anything, you want to go as far left in the SDLC as the tooling allows. Because, in other words, you want to get sooner in the process than later, because if you wait till later, it often causes rework. And the longer you wait, the more potential rework is accumulating, the greater the latency of the feedback, and the slower your process is going to go, the more people are going to be irritated, the harder it's going to be to really have a great tempo and cadence. So the kinds of tooling you want for things like secure libraries, I mentioned Sonatype before, they're friends of ours. I think they do a really good job of that. It's sort of supply chain management. There are other tools, there are free tools for that. I would do it early and as often as you can with any of this policy checking.
Okay, if you're doing any kind of automated remediation at all, won't that conflict with your provisioning tool like CloudFormation?
That's a good question. The answer is not if you do it well. And by doing it well, I mean be aware of the potential conflicts between what CloudFormation thinks is there and what the remediation tool is doing. And there are certain lines you can cross where things like CloudFormation will get confused. So for example, if somebody opens an extra port on a security group or modifies an IAM role, if you put it back to how it was supposed to be, CloudFormation is not going to get confused. So that's fine to do in an automated remediation form. On the other hand, if someone deletes the IAM role, you really need to ask CloudFormation, and this can all be automated, to re-implement it, or it will get confused. Right? So if your remediation script starts shoving stuff into the environment that your provisioning tool doesn't know about, the provisioning tool will get confused. The good news is these integrations aren't all that hard, and at least with products like Fugue, certainly we've built in a lot of intelligence about not doing the things that mess up the provisioning tools. But you do have to know where the lines are, and it's not always easy.
Okay. Is there a good rule of thumb for knowing what your security responsibilities are on AWS versus that of AWS?
Boy, a rule of thumb is tough. I mean, I would say, no, actually I'll come up with a rule of thumb. If there's an API for it, it's on you. So if AWS exposes an API for anything, it is your responsibility to have done it right. So what I mean by that is, There's an API for creating security groups. There's an API for modifying security groups. There's an API for creating compute instances, for creating volumes and whether they're encrypted or not. All that is on you. So if there's documentation that's public, it's your problem. Now the good news is there are things like CIS benchmark, that we've baked in and others have too, where the best practices of how to use those APIs are largely described. And if you've implemented them in policy as code as we have, then the rule of thumb becomes check against benchmark, or check against PCI, or check against HIPAA. So the scope of what's on you, anything with an API on it, that's not a very helpful answer. So the next rule of thumb is make sure you have a tool that can tell you whether or not you are doing it right, according to policy.
Okay, it looks like we can get to one more. Have you noticed any recent evidence of DoD developing or maturing audit criteria for cloud service providers, including AWS and others?
I just have to plead ignorance. I used to work in that space, but it's been a few years, and I don't know the inside pool there, and probably if I did, I wouldn't be able to share it. But I'm not aware of that.
Okay, that is the remainder of the questions.
Well, thanks. Those were awesome questions. I appreciate it.
All right, awesome. Thank you so much, Josh and Drew, for presenting today. And a big thank you to Fugue for sponsoring today's webinar. We really appreciate you guys taking the time to talk with everyone about preventing those AWS misconfigurations and data breaches. The recording of this webinar will be available within minutes of the conclusion. Simply use the same link to rewatch. To view other recorded webinars or sign up for new ones, go to cloudsecurityalliance.org/research/cloudsites. Lastly, if you do have any questions, please email the Cloud Security Alliance research team at research@cloudsecurityalliance.org. Thank you, everyone, for attending today's webinar, and have a wonderful day.